Hey guys, welcome to another one of my videos, and today we're going to be doing part 2 of our energy changes topic. So today we're going to be looking at something called a reaction profile. Simply put, a reaction profile is a graph to show the energy change in a reaction. So get down here, I've drawn them already because they would have taken too long to draw in the video, but down here I've got one graph here that's going to show the endothermic reaction profile, and another graph here that's going to show the exothermic reaction profile. Now, what do you think each of these graphs are going to look like? If you want to pause the video to have a think about this or try and answer it yourself, please do. Please pause the video and just have a think about it. Okay, so I'm going to draw on now how each of these will look. Now on our y-axis, just a short note, we've got the energy. So if the higher up this goes, the more energy it's got in it. Now along this one is the reaction time. So the further we go along this, the longer will have passed since our reaction started. And same on the exothermic graph. So this is how an endothermic would look. Okay, so what does this mean? I'll explain each point to you. This is our reactants. So at this point, so here we have our reactants, and here we have our products. And now you'll notice that the energy is higher here than it is here. And that's because endothermic reactions, if you can remember what we talked about in video 1, endothermic reactions take in energy and exothermic gives out energy. Now, we have a slight up here that comes back down. Now, the reason for this is something called activation energy. Now, activation energy is the energy needed to start the reaction. So, like the splint, you have to put some energy in before anything happens, which is why there is a slight raise here that still comes down, because that's the activation energy coming out. You've put some energy in, and then it's giving that energy out because it doesn't need it. Because the products have all the energy that they want. They've broken all the bonds that they want. Now that you know what an endothermic looks like, why don't you try and think what an exothermic will look like? Pause the video if you want longer to think about it. Okay, so this is what an exothermic will look like. Notice reactants here, products here, a slight raise here because of the activation energy that I've put in. And notice the energy at the start is higher than the energy at the end because exothermic is breaking all the bonds. And here it doesn't, now note, here it goes up and then back down, but with an exothermic reaction it doesn't go down and then back up. It goes up and down, but doesn't go back up. The reason for this is the activation energy has already been spent. As soon as that reaction starts, the activation energy is gone. Can you see? Because it comes down past the starting energy. It has less energy than here, and it's lost more energy than it had here, and that's because of the activation energy. Thank you for listening to my video. Hope it helped you a lot, and please remember to subscribe, leave a like and comment if you enjoyed this and want more videos. See you for now.